Right. Right. I started the modular. Actually, I better wait a sec because I don't know if the stream's gone live yet. I'm not monitoring. I'm not monitoring at the moment. Right. From my past history and back in the 80s or 70s and 80s, me and my dad used to fix vacuum cleaners. That's before I got more deeply into electronics and more deeply into other engineering things. But it was kind of the beginning of learning about things, and vacuum cleaners have always been a fascination. Now, basically, the aerofoils on an aircraft, they behave in a very similar way. You've got to get the angles right to maximize airflow and efficiency. Let's hide the top layer. So I designed these rotors in such a way that as it's rotating clockwise, the leading edge is not directly, if you look at the leading edge, it's not parallel, it's not directly down. There's a chisel edge on the front leading edge there. Now, and on the back of the leading edge, the back of the aerofoil thing, you'll notice it's got a curvature. Now, if you look at an aircraft wing, you'll notice that the wing has a curvature over the top. The reason for that is it creates a vortex, a vacuum. So what you actually have is, in this area, you have a vacuum which sucks air in as the leading edge is cutting through the air. And it's important that the first part of the blade, as it's passing into the airflow, cuts through cleanly and splits the airflow so that there's less drag. So that's the reason why I designed it like that. Now, if you look in a vacuum cleaner, all too often they don't pay any attention to that at all. It's just a flat piece of aluminium that's curved, and it'll be the same thickness all the way along. Okay, that's fine. That's perfectly fine. But what I'm trying to do is focus the airflow so that it has minimum friction as it's cutting into the airflow, and then as the air travels through, you'll notice that it's wider between these points here. So between here and here, it's actually wider there. It's 12.6 millimeters at that point, where at this point here it's about 10.7 millimeters. So we have a faster inrush of air in the center. Now, the reason that's important is because there's less drag at the central point anyway, because of the gear ratio, as in the center point is going to have less of a leverage effect on it slowing down anyway. So as the air moves out through the blades, we need to accelerate that air through the blades, between the fan arrangement, and we also want to give it a bit more room as well, so it can create more suction. Now, what I'm talking about is centrifugal forces of the airflow as it's travelling outwards through this section. The air will basically, I won't say it will expand, that's the wrong kind of explanation. What I mean is that the airflow as it moves outwards will slow down. Now, it will slow down because as you go out to the outer rim of the I think the easiest way to explain it is if you get a nut on the end of a piece of string, right? You tie a nut to the end of a piece of string and you spin it around in a circle around the axis of where you're holding it, and then as you maintain that speed, if you pull the string and shorten it, it will accelerate. That's because the central point of the axis in the middle there the air will naturally want to spin faster anyway. So we have to accelerate that air at this point, and it will naturally slow down as it moves outwards. So we need a bit more room to accommodate the air that kind of accumulates. And as it gets near the outside here, I'm not too worried about the space in there, because it's actually coming out of the rotors at this point. It's actually coming out here. Now, something else I've done, let's unhide that other thing that I hid, and let's actually look at what the next stage is. Now the air is actually, no, I'll leave it unhidden. Now these rotors are spinning clockwise. These are the colour-coded red propellers are actually rotating in a clockwise direction. Now so we have a vortex of airflow that's actually spinning clockwise as well with the rotors. Now the bottom section that's blue colour coded, these are blue, these are stators, these are not moving. So what happens is the air will come out of the top section. I've got to put a can around this, by the way. There's got to be a tube that goes all the way around this. I haven't designed that yet, but this is the reason why the middle one is smaller than the outer one. The outer one will be anchored and wedged between the tube on one side and the tube on the other side. So I'm still making this right now. So the air flies out of here, it comes out of here at speed, and once it flies out, it will also be spinning clockwise. So we have to capture that airflow and funnel it back into between the blue guides. So I've got to basically do a 160, well, not a 160, I've got to do a U-turn basically. Now let's just hide the top section a minute. Right, so let's hide that bit as well. Now you'll notice that these are completely different. They look really weird. They don't look normal. Why is that? Well, because I want the airflow from the top rotation, as the airflow is spinning clockwise, I want to capture it and funnel it back towards the center, so that the airflow doesn't lose its momentum. So we minimize the amount of slowdown and drag basically. On some designs they'll have parallel ribs that come out in a straight line, and that basically acts like a brake. So it's like it will literally just stop the air, it'll stop it, and it causes a lot of drag, much more drag than you would normally want. So by having it shaped like this, I'm redirecting the airflow back to the center for a next stage that goes below it, and the next stage that goes below it is simply, another one of these. So to demonstrate that, let me just get out of here a minute and I'll just close that out. Now let's just copy that. Well, hopefully I won't mess it up when I'm copying it. I need to lock it. So we've got another stage that's going to be, what have we done there? Right, I think that's good enough. There's a gap, but that's fine. So the next stage is another array, and I'm gonna have multiple arrays, because each array will amplify and also gain output air pressure, because once this is being done, it's going to, at some point, it's going to be fed into a turbine, which I've got to design later on. I'm going to be designing a turbine which will be completely different to this, But if you've seen a jet engine, you'll know what I mean. The turbine is basically a bunch of very fine elements that are all focused in such a way that they capture the maximum airflow and give you maximum speed. Now with this though, this accelerates the air in such a way that as you try to, if you stop the airflow, it actually accelerates, so there's very little load factors on the motor that's driving it. Now as the air is travelling through here, we will imagine that we're an air bubble or an air pocket or a piece of air that's flowing through between these things. Oops. Now as it's travelling through here, it will be focused and funneled. I think funneled is the right word, and it will be aimed downwards towards the next stage at the bottom. Now if you look, you will see that the outlet of this section here is in direct alignment with the intake of the rotary fan assembly below it, and that will be sucking air in, so we're not losing any speed. So the air will exit this blue section and it will be drawn down into the next section, the next red section down here, and then the whole process will repeat. The thing is spinning very fast. Oops, I've gone, sorry about that. Right, and we're going very fast. It's hard to steer in it. It's very small space, as you can imagine. We're spinning really fast. We're going down and down and down, and we will come to the outlet. And that outlet will effectively be into another blue section. Right, so the air will come out. It will come out. Oops, I'll just see if I can get this back in here. It will come out. It will hit the inside of a drum. The airflow will be travelling pretty fast, and then we will be. Unfortunately, I can't angle it in such. I can't do a U bend here. It's very difficult to do that. But the airflow will be then redirected down into this next one, which will also go down just like before, and it will go into the next red rotary system that's below it. So yeah, a series of these should increase the amount of output air pressure. So that's the idea anyway. I'm still designing it. It's early stages right now, so I'm taking my time. I'm doing it, so I just thought I'd give you a little update on what I'm doing and why am I doing this. Well, I mean, it's I wanted to do this. It's something I was doing in the 80s with a cardboard vacuum, which I showed in an earlier video. I think I did. Yeah, I did. Yeah. I wanted to 3D model it and do a better design and do some testing with it, because my idea is that I want to create high air pressure and I want to try and harness that in a turbine system to turn a motor, a generator, to see what kind of power we can get out of it. So it's all experimental. It's purely for fun. So as you can see, that's my basic idea, and I'm using a 6mm because I have some drive shaft. I'm using a 6mm drive shaft that's going to go through there, and these spacers will maintain the space in between each section so that nothing can catch and rub on the sections below it. Now there's one loss factor. There's a few loss factors in here in the design, which is difficult to avoid, and that is the gaps between the actually rotary system that's in red and the stator, which is in blue. Now there's gaps, so we're going to have leakage. Obviously there's going to be a certain amount of air that tries to escape back through the system. Now that is why the stator has a very large perimeter coming overlapping the rest of the blades, because there'll be a tube very close to this, so that each section basically will be partitioned off from the previous section, so we'll have minimal losses because each stage will be drawing air in anyway, so the air will want to travel to the next stage rather than leak back on itself, because each section is sucking the equal amount of air, equal amount of vacuum on each stage. But I'm hoping for additional centrifugal forces which will improve the output in the air pressure. Now in some of the vacuum cleaners that were designed many years ago, the stator section, right, that's in blue, had a cover on the top as well, and some vanes that fed in. There's a reason why I didn't put a cover on this, and it's basically going to be, these fins are going to be quite close to this red rotary spinning disc. The reason for that is drag. If I put another flat lid like the yellow one on top, if I put this lid on top of the stator as well, I would have a stationary surface area which would also slow down the airflow. So, and because the red rotary fan is spinning clockwise very fast, it's not going to impede that airflow. In fact, it might even assist the airflow to travel along this conduit, the blue section, because it's spinning already, so the air's already in a spinning rotary mode, and it will assist that airflow travelling through the blue section. However, the base does have a stator on it. It is fixed up my base. Well, I can't do much about that. We need something there to hold the fins in place. Obviously I can't do away with the base, the yellow base stator plate, because those are what the blue fins are mounted on. You know, you can't mount it in thin air. Obviously you need something there, and you can't put individual spokes because that creates even more drag. So it's better to have a flat surface than have spokes connecting pieces together, because spokes create much more drag. So a flat smooth surface will be more efficient, so it'll have to be polished obviously. So, and in between each section there's a little piece of plastic, and this will intersect. This will basically be a very close tolerance, and so the yellow section is not moving, but the red section is. So the red section, which is just inside in here somewhere, hang on. So we have this yellow overlap that's going to feed inside this hole. I'm going to lose myself inside a wall in a minute. There I am, inside a wall. Right, so this is going to overlap, and there's going to be a small gap of about 0.2, 0.3 millimeters. It's probably going to catch and rub at some point, but I'm hoping it'll just wear off, because I'm going to be using some decent bearings on it anyway. So anyway, that's a little bit of a breakdown on what I'm doing at the moment. I'm just going to need to back out of here now because I've got completely lost in here. Right, so yeah, and the only reason I've got this other one over here without anything on it is so you could just get a good idea of what they look like without any plates attached. Yeah, so I mean it was nothing special. The actual design was nothing special. I just used my circle tool to make the curvature and trim the edges off that I didn't want. So to make something like that, it's easy. You just make two circles, and then one circle slightly smaller than the other circle, and then you just trim off the bits you don't want, and you end up with a curvature. Quite easy to do in SketchUp really. So if you look, you can see that they're actually pointing into the airflow, so these are spinning clockwise, and there should be very little drag. Centrifugal force will take effect once the air gets in there, and that will accelerate and use very little power. Yeah, so that's that for now.